Okay, so in this video we're going to solve one of these distance off by 2 bearings problems, but instead of using Table 18 in Bowdish 1981, we're going to use the law signs. And and what I'm going to do here is when you get asked these questions on the Coast Guard exam, they usually ask you your time at second bearing or your time at abeam, not typically both, but in order to do the time abeam, we have to solve for the second bearing anyway. So I'm going to go ahead and just do the whole thing do the solution for both of these problems. And I'll break up after you can see down there in the timestamp of the video. You can pick up whichever part of the problem you want to look at in this video. Okay, so let's just start off by first drawing a diagram. I'm just going to, this line here represents my course, which is we're steaming 114. Okay, great. So I'll say 114. And we're making 17 knots. That's good. I'll need that in a minute. At 11:22, you observe a lighthouse bearing 077. So 077, if this is 114, that's 90. So 077 is going to be up something like this. Okay, so I'll just put this here. That's the light. Okay, so this time was 11:22. All right, and the light bore 077 degrees. So the first thing I want to do is I want to calculate this little angle right here. So that's going to be 114 minus 077, and that's going to equal, what is that, 37, okay? 37 degrees. So this angle right here is 37 degrees. Okay, great. Now, at 11:33, the lighthouse bears 051. So now I'm going to draw a line here that's something like this. Okay, so that direction there is about 051 degrees. 051 degrees. So I want to calculate this angle because I want this angle, but I'm going to need to calculate this angle before I get that angle. So what we're going to do here is we're going to do that this angle here, okay, is going to be 114. Minus 51, and that's going to be 63 degrees. 63 degrees. Okay, so this is 63 degrees. Okay, so that makes this angle right here. That's going to be 180 minus 63, and that turns out to be. So that turns out to be 117 degrees. Okay, so now I need to figure out this angle. Okay, so I'm going to do 180 minus 37 minus 117, and when I do all that, I should get 26 degrees, okay? 26 degrees. Okay, great. So now that's 26 degrees. All right, so now I know these three angles here, okay? And now what I need to do is I need to calculate this distance. So that was 11:22 to 11:33, okay? So, and I'm making 15 knots. So now what I want to do is I want to calculate this distance. What is this distance right here? Okay, so that distance is going to be 11:33 minus 11:22, and that turns out to be 11 minutes. Okay, so now I'm going to multiply that. Now I got to figure out that's 11 minutes of time. All right, times, and that's going to be my speed is, what's my speed? 17 knots. That's 17 nautical miles per hour, okay? And I'm also going to do 1 hour for every 60 minutes, and my minutes cancel out, my hours cancel out. I'm just left with the units of nautical miles, and so it's 11 times 17 divided by 60, and when I get all that, my distance is going to be, my distance is going to be 3.12 nautical miles, okay? So that means up here, that this question mark is now 3.12 nautical miles. Okay, so now what I'm going to do is I'm going to solve for this leg. Okay, so what I'm going to do here is I'm going to use the law of sine. So I'm going to, if I want to know what this leg is, that's x is over the opposite angle. Sine of 37 is proportional to or is equal to. So if I have the distance on the top, then I have to have the distance here in that opposite angle. So that's going to be 3.12 over sine of 26. Okay, so x is going to equal 3.12 times the sine of 37 over sine of 26. So let's do that math here. Okay, I'll get my calculator on here. Let me clear that. And I'll go 3.12 times sine of 37. Now I got to put my parentheses in here to close that out before I do my division. And then I'll do sine of 26, and I hit enter, and I get 4.28. And that's how far I am, is 4.28 nautical miles. And that's at the time of second bearing. Okay? Now, that's the first half, okay? So that's one answer. Now I also want to know the time abeam. So the time abeam is going to be here, okay? So now I know that this leg here, this x, is 4.28 nautical miles, okay? And I know that this angle is 90. That's the angle opposite the 4.28. And I have this angle is 63. And now this is x prime. So to calculate x prime, I'm going to go over here. So this is going to be the time abeam, x prime over sine of 63 equals, that's a 6 there, by the way, equals 4.28 over the sine of 90. Now the sine of 90 is just going to turn into 1. So this is going to equal, x prime is going to equal 4.28 times the sine of 63. And like as I said, you know, this is really over the sine of 90, but that's really 1. So that's really what it boils down to. So x prime is 4.28 times the sine of 63. 4.28 times the sine of 63. And that equals 3.81. And that's the distance off when abeam. Okay, so that's how you solve those problems. Some of you may find that that's much easier to do than using table 18. Particularly in this problem here, you've got two odd numbers, so you'd have 4 factors. Personally, I think this is easier, but you get to decide how you solve the problem. And down on the bottom, I'll put in a link for how you can solve this problem using table 18. Okay, good luck.